Hello guys. So we are back with a really interesting problem. The problem revolves around the idea of symmetry and integration together. So today morning, one of the students asked me this question. I love this question. I've done this question before, but again, like seeing the question after a long time, it like really felt good. So I thought of making a video on this. So let's move ahead. So let's first see the question. And I will see the question number, but I really don't know that from where did he get the question. But since the question is so beautiful, I thought of sharing it right away. So here is the question. The question asks you that it's an integration over here. This integration asks you that the integration is over 1 to 2, 1 to 2, 1 to 2. And here this weird expression x1 plus x2, and it's asymmetry, okay? This is much more important. It's asymmetric and yet I'm calling it symmetrical. So that's the beauty of this problem, okay? We will see how this is like, how the symmetry principle, this idea of exchangeability is so important in integration and probability alone, okay, in statistics alone. So let's explore the problem now. The problem is this. Let's first write down the problem. Problem revolves is integration 1 to 2, integration 1 to 2, integration 1 to 2, integration 1 to 2, x1 plus x2 plus x3 minus x4 by x1 plus x2 plus x3 plus x4 dx1 dx2 dx3 dx4. If you have seen this, like first thing you should feel that, okay, why isn't this plus, okay? So that's a natural thing I felt when I first saw the problem. But here we will see something really beautiful. So instead of attacking this complicated problem, let's try to do an easier problem. Easier problem is just like a brother version or a sister version of this is this. X minus y dx dy and this. So we will show that this is actually same as equal to integration 1 to 2, integration 1 to 2 y minus x dx dy. So it's apparently, it seems like, okay, this must be negative of this, but no, it's equal. It's perfectly equal. It seems like it must be negative, but it's no, it's equal. So this is the most beautiful part of it. It's equal. Why it's equal? Because it's just same as integration 1 to 2. You can understand, like it's like actually you're doing a variable change, and x and y are independent of each other. That's the beauty. You can replace it as x dash y dash, right? Dx dash dy dash. It looks simple. Actually, we have written this in the same way. But x dash equal to x and y dash equal to y. Why we can write this? Because x and y are not dependent with each other, dependent on each other. So they don't depend on each other, and the limit, both are varying from 1 to 2 without any dependence, okay? If it would have been dx square or y is equal to x square, then it wouldn't have been symmetric. So this is what I'm telling, it's symmetric. So it's symmetric in the variables, okay? So we will exactly use the same idea to show that, to find the solution, okay? So this is a beautiful solution out here. So this is same as what? Integration 1 to 2, 1 to 2, 1 to 2, 1 to 2. Just change this x4, okay? So it will be same as x1 plus x2 plus x3 plus x4 minus x3 by this lower wall, everything will be same. And this will be exactly the same, okay? And there will exactly, so we will replace this x4 by all the corresponding all the corresponding variables. So let's see the variables. So what we will get the following. Oops, it's a bad color. Bad sort of. We'll get the following. Let's try to see it. It's equal to I. Okay. So what we will get, it's x1 plus x2 plus x3 minus x4. We have got, I am writing the numerator part, by that thing is there. Top. Another one is x1 plus x2 plus x4 minus x3 is there. Another one is x1 plus x3 plus x4 minus x2. Another one is x1 plus x2 plus x3 plus x4 minus x1. By that same x1 plus x2 plus x3 plus x4 is there. Now, if we add all this up, so I plus I plus I plus I, add all this up, what will you get? Integration 1 to 2, integration 1 to 2, integration 1 to 2, integration 1 to 2. Upper there is what? x1 plus x2 plus x3 plus minus x4 plus x1 plus x2 plus x4 minus x3. There will be x1 plus x3 plus x4 minus x2, and there will be plus x2 plus x3 plus x4 minus x1 by x1 plus x2 plus x3 plus x4 dx1 dx2 dx3 dx4. So this is the beauty of symmetry. Now you just add it up, what will you get? Observe that this cancels only one time with the other. Okay, x2 is already cancelled, x3 is already cancelled, x4 let's cancel over here, x1 let's cancel over here. So we'll get exactly two things are there. x2 is there twice, x3 is there twice, x4 is there twice. So this is essentially equal to integration 1 to 2, 1 to 2, 1 to 2, 1 to 2, twice x1 plus x2 plus x3 plus x4 by x1 plus x2 plus x3 plus x4 of dx1, dx2, dx3 and dx4. This will cancel out to be 2, okay? And all of these lengths are 1. So it's actually integration over a 1 cross 1 cross 1 cross 1, like 4-dimensional cube. Okay, so essentially its integration is 2 because all this length is 1. So therefore what we got? We got 4I equal to 2, therefore I must be equal to half. It's a really beautiful problem based on symmetry. The basic idea revolves around this fact, this symmetry fact. And yeah, so this is the beauty of integration and symmetry, and this is used a lot in complicated problems. I hope you learned something exciting and new from this. So don't forget to like, subscribe and share with your enthusiastic peers. This is our new Cheenta Statistics and Analytics channel. Do subscribe to it. And till then, stay tuned, stay blessed. See you in the next video. Bye-bye.